好，
能看到我的屏幕吗？
可以的，可以的。
是全屏状态是吧？
对。
好的，谢谢。大家好，我是班Qichao，来自青岛理工大学，我是建筑与城乡规划学院的一个副教授。然后这个题目呢是我的国自然题目当中的一部分。下面我开始进行我的这个演讲，然后也是用的英文准备的。好，the topic of my presentation is real-world study and evidence-based practice for smart hospitals. It aims to provide some ideas about the development of smart hospitals from the perspective of healthcare environment design. And the presentation has two parts, including desktop research and system development. In the first part, I will introduce some relevant theories and principles. Then my students, Ms. Zhang, will introduce the second part, the framework of the system. The first is the definition of evidence-based design, an important theory for healthcare environment design. You can see the definition of this theory. It emphasizes evidence. It can inform the design of healthcare buildings and environments to ensure that all decisions about architectural designs are made based on solid evidence instead of personal experience. I will use a case to give more details about this theory. This experiment is famous, and the paper was published in the journal Science. It can be seen as the first clinical experiment that the first evidence-based design strategy came from. It provides 10-year data and statistically meaningful results. You can see the conclusions and the p-values. Before that, we might say plants are useful and helpful for patient recovery, but according to this experiment, we can see plants are useful and helpful because with plant views, patients spend less time in the hospital. The description of health outcomes becomes quantitative. This experiment follows strict rules of randomized controlled trials, which meets the requirements of modern medicine. From this experiment, it is known that all evidence for evidence-based practice should be specific, numerical, and statistically meaningful. For this purpose, modern statistical analysis is necessary. Randomized controlled trials, one of significant science for modern medicine and for modern science, are needed in clinical experiments in order to produce evidence. To count out RCTs, it is important to design controls. We need to know independent variables, experimental groups, control groups, and then dependent variables. Other parameters must be consistent. They should be the same. That's the core of RCTs. These are factors and methods that have impacts on human health based on evidence from RCTs. Architects can use them to think about their designs and decisions to make a better healthcare environment. These strategies are summarized from almost 600 papers. These papers describe clinical experiments and provide statistically meaningful results and conclusions. All these experiments follow the RCTs and design controls and variables. They meet the requirements of modern science. But here is my question. In this complicated world, can researchers create an environment that has a single independent variables in a clinical experiment for those RCTs about built environments? In other words, can other parameters be exactly the same between experimental groups and control groups? Let's go back to that plant view experiment. The finger shows the site where the experiment occurs. The experimental group and the control groups have different orientations and wall types. So do these walls have the same temperature, humidity, air quality, and other stuff? These factors are not discussed in the paper because they are considered as be consistent. But these factors have been proven to be effective to patient recovery. So the conclusion is that this clinical experiment is effective, but according to the limitation of the times, including cognition and technology, the evidence is not precise enough. Therefore, for evidence-based practice about healthcare environments, new methods are needed to avoid some ideal experiments. We use a theory from modern medicine, real-world study, RWS. This theory emphasizes real-world data. It means that all data should be collected as much as possible. Data should cover all aspects of the environment. It's like big data. We need to conduct many rounds of statistical analysis, round after round, to understand the relationship and the effectiveness of all variables and parameters. We need cluster analysis for RCTs in clinical experiments for the built environments of hospitals. Then all architects and researchers can have real-world evidence and use it to make decisions about their designs. The evidence with more considerations and concerns. I do not give RCTs negative meanings, but I think it is necessary to make evidence more comprehensive, precise, and efficient. The ideal conclusions of RWS should be with more controlled conditions, more controls, and more explanations about their function. Okay, let's discuss how we can achieve this goal. The second part, the system development. Ms. Zhang.
Okay, thank you. I'm Man Zhang, and I'm going to give you a brief introduction about the system we developed to help researchers and other stakeholders obtain real-world data and real-world evidence for real-world studies in clinical experiments. Our team is devoted to developing an operating system, including a set of programs and algorithms. This system can be seen as a man-machine coordination process. This system can replace humans when dealing with mechanical labor and provide fast calculation to test the effectiveness of evidence again and again. Next slide. I call this system real-world evidence solutions. It has two parts, hardware part and the software part, which covers the workflow of evidence-based data, including 3 stages: collections, accumulations, and analysis. For the collection stage, we know the workload is excessive. Researchers need massive data covering every aspect, so sensors are applied for the record of indoor physical environments. This method has been widely used for the current research stage. Patients' personal information, including characteristics and hospitalization, is from their electronic health records from medical staff. All data will be stored on the servers. This is the accumulation stage. Some algorithms will be applied for calculation. This is the last stage, analysis. Next slide. This slide shows the logic of analysis. For the first step, all raw data will be defined as independent variables, dependent variables, or undefined variables. Each independent variable can be the target variable, and others will be control parameters. The undefined variables may be corrected parameters. Then they will be categorized into many clusters. Then the second step begins, the data association rule analysis. The computer will use different statistical analysis methods to identify the significant differences, the great changes of dependent variables, the reasons why they change, and what variable cluster change. You can see the calculation process is simple and crude. Researchers many have many invalid results, but when they find some significant differences, they can do in-depth studies to know how. For the current stage, the effectiveness of calculations, if the final results can be used as evidence for healthcare environment design, should be judged by humans. For the next stage, we will use machine learning techniques to design algorithms to let computers do some first-round decisions to further improve the efficiency of making decisions. Okay, this is the framework of this RWE solution system. Thank you.
Okay, thank you. And now the development of this system is in process. We use some techniques including BIM, building information modeling, WarpGL, and 3.js for front-end design and programming. We try to use blockchain techniques for data protection, and we are looking for some technicians for this part. We hope hospitals can use this system to support their construction of smart hospitals. It's like they can do clinical experiments every day from everywhere. And finally, all users can use this system from their PCs and mobile phones to access data and evidence under the authorization. For some issues and concerns, I can also show more details about this system before we obtain patents and copyrights. But if you're interested, you can send me an email or you can leave questions in the chat area, and we can have some communication and cooperation. Thank you.
好，感谢班老师团队关于这个智慧医院的一些研究。好，我们下来李老师是不是还没在？